I welcome you to today's lesson. My name is Paul Williams Ofori. Today we have science for basic 6. So those in basic 6, if you are not in basic 6, please be part of today's lesson. It's very important. The things that we are going to learn, we have already learned it, but today we are going to look at it from different angle. So just exercise patience. Don't move. Don't move. Just look on the board and let's learn. Today, what's the topic? Okay, before we look at the topic, I want to know your name. So write your name at the comment section where you are watching me from. That is what I need from you. And then let's look at the topic. The topic for today's lesson is classes of simple machines. Classes of simple machines. So in our previous lessons, we learned about so many things, efforts and other things. I remember class 1, class 2, class 3, we have learned about machines, simple machines. Today we are still going to look at what? Simple machines. But we are going to look at the classes. You know, machines also have what? Classes. What is a simple machine? I have taught you. So you have to. Or you should be able to tell me what a simple machine is. What is it? Yes, I know you get the answer correct for me. But let's look at the keywords. After that, we go deeper and then you understand what simple machines are and then the classes of simple machines that we have. The first keyword here is levers. Levers. The next one is pulley. Pulley. We have loads. Loads, pivots, pivots, and here is staircase, staircase. So these are some of the words that you find in the lesson. Okay, and you will get to know the meaning, don't worry. We carry out activities in our daily lives. Some activities can be made easy and fast with the help of machines. These machines are called simple machines. So what is a simple machine? A simple machine is a machine that helps us work more easily and faster. Simple machines allow a small force at one point, that is effort, to overcome a big force, that is load, at another point of the machine or device. Examples of simple machines are we have scissors, knives, we have wheelbarrow, we have spanner, hammer, screwdriver, bottle opener, we have pliers, we have crowbar, and then pincers. There are more, but these are examples that we can provide. So now let's look at them. This is scissors. It's an example of simple machine. The next one here is knife. Knife too is a simple machine. We have here wheelbarrow. It's also a simple machine. And then this is what? Spanner, another simple machine. So we've seen that simple machines help us to work more easily and faster. These machines, we use them, they don't use electricity. They don't use batteries. They don't need any source of energy before they can work. So if you look at this, if you want to use spanner, do you need light before, electricity before you can use it? Do you have to get petrol, fill it before you can use spanner or wheelbarrow? No. You just take it and use it. It's a simple machine. Look at the knife. It's a simple machine. Look at the scissors. It's also a simple machine. They all help us to work faster. Okay. We have seen examples of simple machines. We have seen examples of simple machines, and examples are scissors, knives, wheelbarrow. We have spanner, hammer is a simple machine, screwdriver, bottle opener, pliers, crowbar, and pincers. So these are simple machines. So simple machines are put into classes. They are levers, pulleys, and inclined planes. So all the simple machines that we have put them into classes. we have levers, we have pulleys, and then we have inclined planes. So these are the three classes of simple machines. If I ask you to state or write the three classes of simple machines, all the simple machines, the examples that we look at, we can group them, we can put them into classes. So the first class, or the first one that we can mention, is levers. The second one too is what? Pulleys. And then we have inclined plane. So these are the classes of simple machines that you should know. There are three: levers, pulleys, inclined plane. We are going to look at them one after the other. So let's look at the first one. The first one is the levers. So they are simple machines that turn about a fixed point or fulcrum. A lever is made up of the load, effort, and the pivot. The load is also called the output or resistance force. The load is the object. Listen to me. The load is the object that is moved. So the object that is moved is the load. The effort is also called the input force. The effort is also called what? The input force. The effort is the force applied at one point of a lever to overcome a resistance or move a load. So the effort always moves the load. That is the applied force. You are talking about the effort, the applied force at one point of the lever. So now let's come here. A pivot is the same as fulcrum. A pivot is the same as the fulcrum. So a pivot or a fulcrum is a part of the lever that turns at a fixed point. So this is an example of a lever. Here, the fulcrum or the pivot is here. This is where turning takes place. Now, what do we see here? We see load. And what do we see here? This is effort. So where you apply force, that is where the effort is. And then the load, the object that this machine is moving is here. So this is the load. And the part of this machine, lever, that turns is this. And that is what we call the pivot or the fulcrum. So this is an example of a lever. Now, let's continue. It is important to note that there are two forces that occur in levers. The input force, that is the effort, and the output force, or output or resistance force, that is load. All these forces are at different parts of the same lever. When effort is applied at one end of the lever, it overcomes the resistance force, that is the load, at another end and causes it to move. So let's look at examples of levers. So these are examples of levers. They are all simple machines. Here they are all simple machines, but you should know these ones that I'm showing, they belong to one class of a simple machine called levers. Okay, so we have seen this is scissors, this is spanner, we have pincers. Let's look at the next one here. We have hammer. This is hammer. Okay, so hammer too belongs to a lever class. And then we have, this is plier. This is plier. We have broom. Yes, broom too is a simple machine and it belongs to the lever class. We have wheelbarrow. Wheelbarrow too is also a simple machine and it belongs to lever class. We have bottle opener. We have knife. Okay, so these are examples that you should know. All these are simple machines, but they belong to one class of a simple machine. That class is what? Levers. So if you are asked to give examples of simple machines that belongs or fall within the class of levers. These are the examples that you're expected to give. Okay. Now, there are three classes of levers, and they are the first class lever, the second class lever, and the third class lever. Even among the examples of levers, we have different classes. So we have classes of simple machines and then classes of levers. Classes of simple machines are the levers, pulleys, inclined plane. And then if you take lever or levers, we have classes. We have first class lever, second class lever, and then third class lever. So let's look at them. Now, the first class lever are machines that have the pivot located between the effort and the load. Examples are scissors and screwbar. Let me show you something here. So let's say we have this. This is a lever. Let me change the color. And then we have this side here. Have you seen it? Let me change it again. We have a box here. Now, this is a lever, but it has three parts. Let's try to identify the parts. Where is the load? Where is the load? This is the load. This is the load. And then, where do we apply the force? Where do we apply the force? We apply the force here. This is the part that you hold, this part. So this is what we call the effort. So you see, we apply force here. So the effort is here. And then this is the load. This is where the object is. Now, which part of the lever turns? The part that turns is the pivot or the fulcrum. So here, this is the part that turns. So this side is what we call fulcrum or pivot. So you should know this side. Effort stand or E stand for efforts, F stand for fulcrum, and then L stand for load. So if you are asked to label the parts, if I draw something like this and I ask you to label the part, you should know where the object is. The object is the load. Where we hold and apply force, that is the effort. And then the parts of the machine that turns is what we call the pivot or the fulcrum. So this is how the parts are labeled. Let's go back. So we have seen that we have first class, second class, and then third class. Now let's look at the first class. We are saying these are the examples. And with the first class levers are machines that have the pivot located between the effort and the load. Examples are scissors and crowbar. So this one, we have the pivot at the middle. The effort and the load are at the other side. So the one that I drawn here, this is first class lever. This is first class lever. Let me clean. So here the first class, the pivot is at the center or in the middle. The pivot is the same as the fulcrum, it's in the middle. We have the effort at one end and then the load at another end. Okay, so here first class, we have what is in the middle. The one in the middle is the most important thing. Always make sure that you'll be able to know what is at the middle or in the middle. Now here the fulcrum is in the middle. Obviously it, and we have effort here, we have load here. So what is in the middle is the fulcrum. Because of that, this is first class lever. Now first class lever, let's go back. Now, so examples of machines that fall within first class lever, we have scissors and then we have screwbar or crowbar here. Here, the scissors, this is the part that turns. The part that turns is in the middle. Here is the load. Let me show you. So this is the load. This side is where you put the material, where the material will be. So that is where the load is. If you put stone here, you see how you struggle before, even if you can cut it. So whatever that you put here is the load. So this side is the load. Now the part that turns, this is the part that turns. So here is the pivot or the fulcrum. This is the load. And the part that we hold, we apply force. That is the effort. So this is the effort. So look at it. And you can see that the fulcrum is at the center, it's at the middle. So any simple machine, any lever that has the fulcrum or the pivot at the center, in between the load and the effort, that one is first class lever. Okay, let's go back. If you come here, the same thing. If you come here, the same thing. Which part of this do we hold? We hold this side. So the part that we hold, that is where we apply the force. That is where we apply the effort. So here, this is effort. Have we seen it? Okay. And then here, which part of these performs the actual job? Hold the object, touches the object. This one we use it to remove nails. Which part of it removes the nail? This side. So this is the part that the whole work is done. So here is what we call the load. This is where the load is. And this is the part that will be in the middle, turning. So this side is the fulcrum. So when you talk of first class levers, always the fulcrum is at the center. So we have this, and this. The fulcrum is at the center. So this is why crowbar is a first class lever. Okay, let's go back. Now we have another one, second class lever. So second class levers are machines that have the load located between the pivot and the effort. Examples are wheelbarrow and bottle opener. So here, this is second class lever. That one has load at the middle or in the middle. So here, this is one part. This is one part, and this is another part. Which of these parts do we put the load? What do we use this for? We use it to carry things. So let's say you have books or you have sand and you want to send it. You want to carry it to different places. Where will you put the sand? You put the sand here. So this is where the load will come. Inside here. Where will you hold? So this is the load, right? Where will you hold? You hold this side. The part that we hold, that is what we call the effort. We apply force there. And then this is the part that turns, where we have the tie, this is where the turning takes place. Here nothing turns, here nothing turns, the turning takes place here, and the part that turns is called what? Pivot or fulcrum. So here, which part or which one is at the center? This is the one at the center, the load. So with the second class levers, the load is at the center. The load is at the center. So take notice. Always the load is at the center. With the first class, the pivot or the fulcrum is at the center. But with the second class, the load is at the center. And then we have the efforts and the pivots or the fulcrum at the other end. Okay. So second class lever. Second class lever. The one at the center is the load. And then we can have efforts here, we can have fulcrum here. So always the attention is on the one at the center. First class lever, fulcrum is at the center. Second class lever, load is at the center. So if the one at the center is correct, we can interchange this, the one here. So here, the effort can come here, load can come here. This one too, if the load is at the center, the effort can go here, and then the fulcrum too can come here. That one, if you arrange it like that, you don't have any issue. But make sure that the one at the center for first class lever is the fulcrum. The one at the center for second class lever is what? The lever. Sorry, the load. The load. The one at the center for second class is what? The load. The one at the center for first class is the pivot or the fulcrum. Now let's go back. Let's look at third class lever. So third class levers, they are machines that have the effort located at between the load and the pivot. Examples are shovel and broom. So here the effort is at the center. This one, the effort is at the center. Which part do we hold? And we apply more force. It is this side. This is where we hold. Where is the load? Which part fetches the sand? This side. So the load comes here. And which part do we turn? This is the part that we turn. So if you want to turn the shovel, this is the side that you turn. But here is where the effort is. Here is where the effort is. You can't just hold this side and fetch sand unless you hold the middle. The middle is where you apply the energy, you apply force. So that is where the effort is. So here is the effort. This side is the load. And this side is the pivot. I've told you that pivot is the same as the fulcrum. Have you seen it? So if you look at this, you can see that what we have in the middle here is the effort. So with the third class levers, the effort is at the center. It's located between the fulcrum or the pivot and the load. So let's go back and do this thing. Let's go back and I want to show you something. So when you come here, we have first class, second class. Let's look at it. Other one, third class. So this is third class. Third class, what do we have at the center? We have effort at the center. So if effort is at the center, load can come here. Load can come here, or we can bring fulcrum here. So here, let's bring fulcrum, and then we have load. We always pay attention to the one at the center or the one in the middle. So you see, first class lever, second class lever, third class lever. What do you have here? So the first one here is F. Second class, what do you have in the middle? L. Third class, what do you have in the middle? E. Have you seen it? So this is first class, second class, third class. So anytime you are asked to draw something, first class lever, second class lever, third class lever, you should know that first class, the F is at the center. Second class, the L is at the center or in the middle. Listen, first class lever, the fulcrum is located in the middle. Second class lever, the load is located in the middle. Third class, the effort is located in the middle. So FLE. This is what you should know. If you are able to get this equation, you'll be able to answer all questions. Now you see, first class, we have fulcrum at the center. So fulcrum here. Second class lever, we have load at the center. So L is here. Third class, we have E at the center. So we have it here. Understand this and you'll be able to answer all questions. Let's go back. Now we are going to look at the next class of simple machine. But let me show you a video before. I want to show you a video. Let's look at this video. We are looking at levers. So look on the board. So you see, let me start. So you see, FLE. The F stands for what? Fulcrum, load, effort. So first class, we have this at the center. Second class level, we have this at the center. Third class, we have this at the center. Let's continue. So we have 1, 2, 3. This is first class, second class, third class. The one that you see on top, they are found in the middle. Now let's continue. So you see examples. Okay. So this is what? An example of levers. Okay. So if you look at this is the first class, second class, third class. Now it is not only in object that we can find levers, even in human beings, our body parts. Yes. So first class lever, we have fulcrum at the center here, effort is here, load is here. Second class lever, we have load at the center, we have effort, and then we have fulcrum. And then third class, we have effort at the center or in the middle, and then we have fulcrum and then load here. So this is how we arrange them: first class, second class, third class. Now human beings, our body parts, which one falls under first class, second class, and third class lever? Look at this. So this is the load. Look at here, your neck, fulcrum, you'll be able to turn your neck. So the load is where you put the food and you chew. And then the back here is the effort. The same thing comes here. The same thing is here, the part of the body. So the fulcrum is here, the soles of your feet. And then we have here, that is the load. And this side, the effort. The load is at the center. So this is the load. Have you seen it? So the load is always in the middle. With the second class levers, the load is always in the middle. Now, where is the effort? The effort is where we hold, where we apply force. So this is the effort. This side of it is the effort, and the path that turns is here. So the path that turns is what? The pivot or the fulcrum. So if you look at it, this is represented here. But here is the effort, the part that we hold. The load is here, and then the fulcrum is also here. So that is that. Now let's continue. So this is the effort, this is the load, this is the fulcrum. Okay, another one too is here. If you look at this, this is the load. This is where we hold. That is the effort. The part that turns is here. That is the pivot or the fulcrum. So that is that. Let's continue. We have the same second class. So now let's look at third class lever. So with the third class lever, I've told you that the effort is at the middle. The effort is located between the load and the fulcrum. So this is third class lever. Now let's continue. So if you look at this is the load, this is the effort, this is the fulcrum. So here is where you apply force. This is where the object, this machine will touch the object, and then this is the part that you turn to direct the load. Okay, so this is third class lever. Let's continue. So you see the man is what? Sweeping. You see the hammer here, fulcrum, effort, and the load. So this is all that you need to know about classes of lever. We have first class, second class, third class. You see, with the first class, we have fulcrum. This is a fulcrum at the middle. Second class, this is the second class. We have load at the middle. Then third class, we have efforts at the middle. So 1, 2, 3, first, second, third. What we have on top are found in the middle of the machine. Okay, so that is all that you need to know. If you have questions, feel free, but let's watch and see. So second class, and then this is the one in the middle. Third class, this is the one in the middle. So that is that. Okay, let's go back. Now we are finished with the first class of simple machine, that is levers. We have seen that we have first class, second class, third class. For you to know that this simple machine is first class, second class, third class, check the parts that is found at the middle. So if the one at the middle is a fulcrum, then it means it belongs to the first class. The one found at the middle is load, that is second class, and the one found at the middle, if it is effort, that is the third class lever. Okay, so this is what you should understand. Okay, we are going back. We are going back. Now, the next class of simple machine that we are going to look at is the pulley. So what is a pulley? A pulley is a simple machine that uses one or more wheels and ropes to lift or move objects from one place to another. The types of pulleys are the fixed pulley, movable pulley, and compound pulley. A fixed pulley does not move but has a rope or ropes that go around it. A fixed pulley is attached to one point and changes the direction of the force. Examples of fixed pulley are well and flagpole. So if you look at this, what do you see here? I can see a rope. Have you seen it? The rope is attached to a bucket here, and then we have a wheel. The wheel, we have the rope, around it. Have you seen it? So if you pull it, it will lift the load. If you pull the rope, it will what? Lift the load. Okay. So this is what? Example of a pulley. Another one too is here. Look at the boy. So the boy too is pulling what? The flag. So the pulley is on top here. Okay, we can't see it, but I will show you video. You understand it. So that is a fixed pulley. You see this one, it is fixed, it doesn't move. This one too on top, it is fixed, it doesn't move. Now let's come here. Movable pulleys are able to move freely. An example is the crane. So if you look at this, the wheels are here, but you can move them. That is why they are called movable. Okay, let's look at some videos here. So take your time and watch this. So this is by engineers. Yeah, this video is by engineers. Okay, so this is how pulley looks like. Pulley, this is how it looks like. Have you seen the roofs? Okay. So it is used to lift objects. Look at this round thing. So this is pulley for you. So fixed pulley, this is how it looks like. You see fixed pulley. Have you seen it? So here is the effort. You pull it and the load will move up. The same thing is here. You pull it and then the load will move up. So yes, this is the rope. The pulley is here. You see the rope. So with the flap, we can do, or we can move it with the help of the pulley. Okay, so fixed pulley, movable pulleys. So with the movable pulleys, look at it. Here, the pulley is moving up. Let me go back and show you something. Oh. So if you look at this, you see that this is fixed. This one cannot go up. The wheel cannot go up. It cannot come down. But here, the wheel can move up. Let's look at it. The wheel can move up. Let's look at it. Look at the wheel here. Have you seen it? Okay, have you seen that it's going up? It can move up, but this one, it is fixed. It can move up, but this one can do that. So let's look at it again. Have you seen? Okay, so this is movable, and this is an example. This is clean. This one, you go to ports, they use it to lift containers and other things. At the construction site, they use it to lift mortar, blocks, and other materials. So you see, we have fixed pulley, movable pulley, and then system of two pulleys. That is the compound one. Okay, so here we have fixed pulley and movable one. So the rope is attached to the fixed one. At the same time, it's attached to what? Movable one. So this is system of two pulleys. That is the compound one. Okay. So here you apply effort. With this one, we need small effort to lift heavy load. But this one, because it is fixed and it's only one wheel, you struggle. So these are our examples of pulley. Okay. One day you find yourself in an industry, you get to know these machines and you understand that pulley is very important. Those who want to become engineers, contractors, these are the things that you need to lift your things, your items. Okay, so these are all videos about machines, pulley machines. So credit to next generation science. In fact, they help us get this video. Okay, now let's go back. let's go back. We are finished with levers. We are finished with pulleys. The next class of machine is inclined planes. So they are sloping platform on which a heavy object can be moved or rolled from one place to another. Inclined planes help us move heavy objects with less energy. Examples are ladder, staircase, and slide. So if you look at this is an inclined plane. This is a ladder. Okay, we have another one here, staircase, and then we have this one, slide. So this one help us to move, you see. Okay, now if you are asked to give examples of machines that fall under inclined planes, so these are the examples that you can give. Okay, let me see if I have video for you. I should have a video for you. Okay, so let's look at the video for the inclined plane. So you see this? Okay. Now look at it well, watch it well, and tell me what you see here. So have you seen the car? Okay, very good. So this is the inclined plane. Let me go back and show you. This is the inclined plane, this one. Have you seen it? Okay. So this is where the effort is and the load. Okay. Have you seen this one too? Another one. Another one too is here. So it helps us to move. Look at the staircase here. So all these are examples of inclined plane. Okay. So let's go back. Let's go back. So this is what an inclined plane is. They are sloping platform on which a heavy object can be moved or rolled from one place to another. Inclined planes help us move heavy objects with less energy. Examples are ladder, staircase, and slide. So these are some examples. We have also watched the video, we have seen different examples. Now let's move on. Proper ways of using simple machines. So if you have simple machines, today we have looked at simple machines, the classes that we have for simple machines. Now we are going to look at how to use simple machines properly. Now the first one, choose the right type of machine for the right job. So if you want to carry load from one point to another point, please, Fibalo is there, use it. Don't use spoon. Don't use spoon to fetch sand. Use Fibalo. Or don't use spoon to carry sand from one point to another point. Use Fibalo. It is used for that. And if you want to eat food, let's say you have porridge, you want to eat your porridge, use the right tool, please. Don't use knife for porridge, use spoon. Okay, the next one is handle sharp tools with care and keep them in a toolbox when not in use. So if the simple machines, the sharp tools, if they are not in use, please make sure you keep them in a place that will not what, a safe place, because these sharp tools can hurt somebody, it can destroy something. Okay, so anytime sharp tools are not in use, we are not using them, we should make sure they are kept in a place that people will not have any effect. Okay, now the next one is that pay attention to the machine and the work when using it. There are some people, whenever they are working with a machine, their attention is divided. one part of their attention will be on the work that they are doing, and then they'll be thinking about something or looking elsewhere. So please, if you are using the machine, make sure you give your full attention. Okay, the next one is that hold the handles of simple machines when using them. So if you are using simple machine, make sure you hold the handle, don't hold the other parts, otherwise you'll be in trouble. Number 5, do not use faulty machines, but fix all faults before using them. So if you are going to use a simple machine and you realize that the machine is faulty, please stop, don't use it. Make sure you fix it before you use the machine. If you do that, you'll be protected. So these are the proper ways that we can use simple machines. Okay, so there is a project here. Design and make a simple machine of your choice from appropriate materials such as bamboo, wood, cardboard, plastic, paper, straw, cane, and things. Okay, now we have here the summary. We have learned about simple machines. They are machines that help us to do work or do our work more easily and faster. Simple machines are in 3 classes, and they are lever, pulley, and inclined plane. There are proper ways of using simple machines to make work easy and fast. So this is what you have learned today. I want you to take your time, watch the video again. Now let's look at the exercises. So we have exercise 1 here. We have exercise 2. We have exercise 3. Exercise 4 is here. And then we have our home assignments. So these are the exercises and the homework that I want you to do. Take your time and do them. They are simple and easy. Okay. My name is Paul Williams. Remember to get a copy of this book. The title of the book is Kokomoti series. It is not only science that we have Asante tree, we have a tree. Our videos are on YouTube, TikTok, and Facebook. Please, after watching, share the link, subscribe, comment. Okay. Thanks so much. Bye-bye.